This is a video explaining the implementation of the given function prototypes using linked lists. So like we were given assignment to be written in C programming language. In the assignment, some functions were already defined and created for us, like the create node function, which is passed create node function on line 10, which is passed an integer variable now. And then we see that memory, like we use the malloc function to dynamically allocate space in memory for our new node that we are going to create, whose pointer is named new node. Then the size of the node is going to be size of struct node, whereby we have a structure named node with parameters or members, number and next. And we see that this pointer next on line 7 contains the address that points to the next node if we are to create a new node. So we see that on line 13, if the new node that we've created happens to be created in memory, or doesn't, in this case it does it. If the new node is equivalent to null, that means it's empty, or like it hasn't been created. Then we send an error message to the screen. And then if the new node we created using the create node function is created, we see that on line 17 we assign the node with a member number and next to that node, and then we return to the new node. Then after that is a function print list that was already defined for us, and this function is going to print out the list of the numbers in the node or in the nodes that will be created and will happen to appear in our linked list. Then there's a function 935 void append. Void append enables us, like it's created in a way to enable one to add a new node at the end of a linked list, at the very end of a linked list. So we see line 36, we call the function create node and assign a variable num to it, and then assign it to point a new node. So this point a new node is going to point to the newly created node. And then after that we will loop through the list using if and while functions until we reach the end of the list where a new node is going to be added. So on line 45 is the line that enables like enables for the adding of the new node at the end of the linked list, where we see that using the current pointer, current is able to loop through the entire list until it reaches that node whose next parameter is null, and then we'll know that that is the end of the list. Then we have to add our new node after that last node in our list. So line 45 enables one to create a new node in the list by assigning the pointer that we've been using to loop through the entire list with the new node. Then we have the function on 947 void prepend. Void prepend made in a way that it enables one to add a new node at the very beginning of the list. So by passing it with two parameters, we use the struct node and following the function create node enable us create a new node. And by creating this new node, we assign it to the new node pointer. Therefore, the new node pointer is pointing up to our newly created node. And since we have star head, like the head pointer already pointing to the first node, we will have to get the new node and that part of the new node that contains the address to the next node, and then the head pointer is assigned to that address so that we can have the new node being linked to the rest of the nodes. And then we have 952, we have the function delete by key. This function delete by key is going to enable us to delete a node by entering the key of that node. And according to my own understanding, the key of the node is the position of that node in the linked list. It could be position 1, position 2, position 3, but yes. Then we create a pointer current and assign it to the head pointer so that they are both pointing in the same location at this place. And we are going to use this current pointer to loop through the entire linked list if it has more than one node and be able to find that node with the number parameter that matches to our key that's been entered. Then on 957 we have the if condition. This if condition enables us to check if the very current node that we are looking at, which is the first node, is the node whose number is equivalent to the key that's been entered. Then if it is so, 958 we see that the address, like the address part of that current node, is assigned to the head pointer. So the head pointer is pointing, so the head pointer is pointing to the, like, going to get linked to the node that's after this current node we are looking at. So then after that, in order to delete that very node, we have to free the space of that node where the current pointer is pointing at the very moment. Then after this if function from 957 to 960, we work for the very first node. But if the first node isn't the one with the number that's equivalent to the key, then we use a while loop to loop through the remaining part of the remaining nodes of the list. And there in 965 we said there is a possibility of not having a node with any number inside. In other words, having a node that's empty. And then 967 enables us to link the previous node to the node that's after the node we want to delete. Therefore, it unlinks this node we are looking at to delete from the list by linking the previous node using the previous pointer to the node that's after the current using the addresses. And then by doing so, we also have to free 968. We have to free the space that has been occupied by the current to confirm its deletion. Moving on to delete by value function on 971. Delete by value is not so different from delete by key, I assume. So we do the same thing on 973. Start by assigning the pointer head to another pointer current, and in doing so we use a while loop Once again, check the validity of the first node if it contains the value. The value in this case, I think it's like the number that's being held by that node. And then we have another while loop on line 82 that loops through the entire list to check if this CURLT pointer that we have assigned to loop to traverse through the entire list is equivalent to null, and if not, we have all these functions being executed until line 90, probably until we find them, until we come across a node that we need to delete. Then moving to line 94, in line 94 a function is called insert after key. This function insert after key is going to enable me to be able to insert a node after a given key, a key that's probably entered by the user. So under this function of insert after key, I will assign the head pointer to the CURL pointer so that they are pointing to the same position. And this CURL pointer is going to traverse through the what? The list and look for that number, that node whose number is equivalent to the key. So after finding that node whose number is equivalent to the key, we have to create a node, a new node after that position of the node. We want to create our new node and assign a value to it. So we use the malloc function and allocates memory for a new node that will be the size of the struct node. Line 100 we assign a new number, assign value as the number parameter, and then we link the new node to other nodes using line 101. So we assign the new node to the other nodes using those lines. Then moving on to insert after value. Insert after value enables us to insert a new node once again after a number that's equivalent to the value that's been entered by the user. So doing the same thing like above, we use a while loop to traverse through the linked list and using a pointer present, assigning it to the head pointer so that it's pointing from the very start of the linked list. The present pointer loops through the list. Present not being now, it will loop through the list for whichever node isn't empty. And so if on line 111, if the present pointer is pointing to say a node whose number is equivalent to the search value, then that means we have found the value after which we want to create a new node. So we allocate memory space, which is size of a struct node for a new node. And this new node, line 113, is assigned with the new value that's entered as this number. And then line 114 enables us to link the new node to the rest of the list. Then in the main function, we were asked to use switch case I think switches. And for switches take switch takes on one argument in this case, which is a choice, and it has cases and different cases, say case 1, case 2, and if the cases are not executed, then we'll have a default value that will be executed instead if the conditions of the cases aren't met. So in this case, in this situation, our case one is to print a list. That's to print the list starting from the head of the linked list probably to the end. Case two enable us to append data to the list. Case three will enable us to prepend data to the list. Then case four will be for deleting by key or by value. Then finally case five for exiting. And then we have the default parameter. So let me try to run. So here the user enters their choice on this printed list. If they want to print a list, and I think one would have to first append information in order to be able to print the list. So when you enter data multiple times, our list will be created and we'll be able to prepend, to append, to insert, and to be able to delete elements and all.